when you are doing any work, when you are doing any work, do not think anything beyond. Do not think anything beyond. Do it as worship. Do it as worship, as the highest worship, and devote your whole life to it. As the highest worship, and devote your whole life to it for the time being. For the time being, by Swami Vivekananda. Hi everyone, this is Akshay, Faculty of Mathematics, Vivek Vidya Youth Forum, New Delhi. So, over here, I have taken your NCERT textbook itself and I will be writing it on your textbook. I suggest take a pencil, keep it handy, keep your textbook handy. If you don't have textbook, later on you can just write down your notes, whatever is displayed on the screen, whatever is typed on the screen, copy it down and write it there only in pen. Copy the notes in pen, write it in pencil, whatever I write on the screen. Okay. So use Euclid's algorithm to find HCF of these two. Use Euclid's algorithm to find HCF of these two. We know 12576 is greater than 4052. So by applying division lemma for this, we get 12576 can be written as 4052 into 3 plus 420. So how did you write this? Let me just express it over here. So I think so. I can write it over here only. So we have 405. Or no, wait. I will share a white screen here. Corresponding white screen I will share. Hope my white screen is visible. 4052. Just a minute. Wait. Four zero five two divided by 12576. 12576. If you further see how it is 127576, it is 3 times 12156. Reminder, we will be getting it as 420, which can be further expressed as 12576 is nothing but 4052 into 3 plus 425. Sorry. Just looked at it. 420. So that is what we have written over here. You can see the underlined part. This is nothing but a same. This is nothing but a same. Similar way, the remainder what we have got 420 is not equal to 0. So therefore, again division lemma applies for B and that one. What is B over here? B is 4252 and this one. So we will apply over here and we will get 272 as the remainder, which is again not equal to 0. So again division lemma applicable. Next step. Similar way you will do the division lemma. Next. Again you get it as 148 as the remainder, which is not equal to 0. Again the application of division lemma. We are getting 124 as the remainder, which is not equal to 0. Application of division lemma. Getting 24 as the remainder which is not equal to 0, application of division lemma. Getting 4 as the remainder which is again not equal to 0. Further step, we will get 0 as the remainder, so we will stop the process. Now, the remainder now becomes 0, so the procedure stop. Since the divisor in this stage, this is the divisor. In this stage, this is the divisor. So divisor in this stage will nothing but be the HCF of both the numbers. It is the HCF of both the numbers. Okay. 4 is HCF of all these sets. Okay, 4 is HCF of all these sets. So you can later on say Euclid's division algorithm is not only useful for calculating HCF of very large numbers, but also useful because it is the one of the earliest example of algorithm the computer has been programmed to carry out. Then there is something called as remark. So remark here is nothing but the concept inside. Remark here is nothing but concept inside. Euclid's division lemma and algorithm are so closely interlinked that people often call Farmer as the division algorithm also. So this thing is actually not required. This point I don't connect it and I don't say children to remember this point. But the second point I say, remember, although division algorithm is stated only for positive integers, it can also be extended to all integers except the 0. However, we shall not discuss this in our syllabus. In our syllabus, we won't be discussing this, but this you can take it as an extra. You can take this as an extra. Question number 2. Show that every positive even integer is of the form 2q and that every positive odd number is of the form 2q plus 1 where q is some integer. So let's begin the solution like this. Let a be the positive integer and b be equal to 2. Then Euclid's algorithm a is equal to 2q plus r. So we know over here a is equal to bq plus r, we don't know. So b is 2 over here, 2q plus r. And q, we know it's greater than or equal to 0. Q, we know it's greater than or equal to 0. And r is exactly equal to 0 or it's 1. Because r lies in the range between 0 and minus 2. So a is equal to 2q or 2q plus 1. If r is 0, a will be equal to 2q. And if r is 1, a is equal to 2q plus 1. So a is of the form of 2q. Then a is an even integer. Also, the positive integer can be either even or odd. Therefore, a positive integer is of the form of 2q plus 1. If it is 2q, if any multiple of 2 is an even number and 1 plus the any even multiple is nothing but the odd. This we are all aware of from our lower grades also. Let's see with the third one. Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3 where q is some integers. Let us start by taking a, where a is the positive integer. We apply division algorithm with a and b equal to 4. So here you remember one thing. 0 less than or equal to r less than 4. R lies in this range. So the reminders can be only these can only be the reminders. So A can take these values 4q, 4q plus 1, 4q plus 2, 4q plus 3. Where q is the quotient and A is odd and it cannot be even multiple. 4q is an even, 4q plus 2 is also an even. So both are divisible by 2. So those two will be ignored. And in the question, they have given odd multiples. So the odd multiple is of the form of 4q plus 1 or 4q plus 3. Either of the form. Next. A sweet seller has 420 kaju burfis and 130 bada burfis. She was stock them in such a way that the stock has same number and they take up the least area of a tray. What is the number of place the stock for this purpose? What is the number to place? Again, all these types of questions are very important. This is the applications of Euclid's division lemma. This is done by trial and error method. But to do it systematically, we need to find the HCF of both 420 and 130. Then the number will give us the maximum number of burpees in each stock, and the number of stocks will then be the least. The area of the tray which is used will be the least. Now let us use Euclid's algorithm to find the HCF. So as I have told how to use Euclid's algorithm using the white screen before in the previous question, similar way you will solve here also, right? Then 30 we have got over here, 30 which is not equal to 0. Just a minute. So 30 here is not equal to 0. So again, the division lemma proceeds. We get remainder as 10, which is again not equal to 0. Division proceeds and we get remainder as 0. So here the process stops. What is the divisor used here? Here it is 10. So 10 is the HCF of them. Of both of them, 10 is the HCF. And Sweet Seller makes a stock of 10 for both kinds of burfies. He keeps a stock of 10 for both kinds of burfies. So what all we learned over here? Application of Euclid's algorithm and how to use Euclid's division lemma we learned. And how many steps till where you have to solve. Till you get 0, you have to solve it. And then few application problems, as I have told, are important over here. So concept is pretty simple. You can get hold of this. Thank you. Before ending this, if you have liked this video, please click on the thumbs up button, share this video, post your doubts in the comment window. We'll surely get back to you. Thank you.